Now I'll explain how to reduce given quadratic form to canonical form using orthogonal transformation method. So this is the general form of a quadratic form in three variables. Its canonical form is given by q equal to lambda 1 y1 square plus lambda 2 y2 square plus lambda 3 y3 square, where lambda 1, lambda 2, lambda 3 are eigenvalues of matrix A, where matrix A is the symmetric matrix associated with the given quadratic form. So, to obtain canonical form of given quadratic form, first we have to write the symmetric matrix associated with the given quadratic form. Then we have to find out the eigenvalues of that matrix. Finally, we can write the given quadratic form in terms of canonical form once you obtain all the all eigenvalues. Three eigenvalues if it is a quadratic form in three variables. Let's illustrate this with an example. Obtain the canonical form of the quadratic form 8x square plus 7y square plus 3z square minus 12xy minus 8yz plus 4zx. First, let us write the matrix of this quadratic form. The first is coefficient of x square 8, then half into coefficient of xy minus 12 by 2, that is minus 6, then half into coefficient of xz, that is 1 by 2 into 4, that is 2. Then this row is for y, coefficient of yx minus 12 by 2 minus 6, then coefficient of y square, diagonal is for y square, that is 7, then coefficient of yz, which is minus 8, minus 8 by 2 is minus 4. Then coefficient of the third row, it is for zx, zy and z square. So coefficient of zx is 4 by 2, which is 2. Then coefficient of zy is minus 8 by 2 minus 4. Then coefficient of z square is 3. So this is the symmetric matrix associated with the given quadratic form. Now we have to write its canonical form. Canonical form standard form is lambda 1 square y square plus lambda 2 y2 square plus lambda 3 into y3 square. So this is how we have specified here, where lambda 1, lambda 2, lambda 3 are eigenvalues of A. Let us find out the eigenvalues of the matrix A. It is a 3 by 3 matrix. We have the way of finding eigenvalue is writing the characteristic equation, then simplifying that characteristic equation. We can get the characteristic equation directly, that is given by lambda cube minus trace of A into lambda square plus A11 cofactors of diagonal elements A33 into lambda minus determinant of A equal to 0. So this is the characteristic polynomial associated with the given 3 by 3 matrix. This is the standard formula to remember. Now find out the trace of A. Trace means the sum of diagonal elements, that is 8 plus 7 plus 3 into lambda square. A11 means cofactor of the element in the first row and first column. So delete first row, first column. You will get the determinant 7 minus 4 minus 4 and 3. Find the value of this determinant. 7 3 is 21 minus 16 here. So it is equal to 5. This first value is 5 and its sign is positive because plus minus plus minus plus minus plus minus plus. So all three diagonal elements will have the sign positive when you are finding the cofactors. A22 means delete second row, second column. Then you will get the determinant 8, 2 and 2, 3 because deleting second row and second column. So this gives a 24 minus 4, that is equal to 20, plus A23, delete A33, delete third row, third column, then we will get the determinant 8 minus 6 and 7. So cross multiply and get the value 56 minus 30, that gives you 20. into lambda minus determinant of the given matrix. We have to find the determinant of the matrix. It is 8 into first row, first column you delete, 21 minus 16 minus of minus 6 into delete first row, second column, minus 18 plus 8 plus 2 into delete third row and first row and third column, will get 40. This is equal to 5 plus 6 into here minus 10 plus 2 into this is 10. So this gives you it is equal to 0. So determinant value is 0. Let me substitute all this here. So what I'll get is minus it is 0 equal to 0. Just all I'll erase this. Now let us simplify. You will get lambda cube minus, as it is singular matrix, 0 must be one of the eigenvalue. So here I'll get 18 lambda square plus 45 lambda equal to 0. So when you take lambda common, lambda square minus 18 lambda plus 45, which is equal to 0. Next, therefore lambda equal to 0 is one of the eigenvalue. Then lambda square minus 18 lambda plus 45 equal to 0. Let us factorize this quadratic equation. Lambda square minus 15 lambda minus 3 lambda plus 45 equal to 0, because 15 3 is 45, and here minus minus becomes plus. 15 minus 15 minus 3 is minus 18. So lambda into lambda minus 15 minus 3 into lambda minus 15 equal to 0. That is lambda equal to 15 comma 3. These are the roots of this quadratic equation. Therefore, we have eigenvalues. Eigenvalues are lambda equal to 0, 3, 15. Hence, quadratic canonical form of the given quadratic form is Q equal to lambda 1 y1 square plus lambda 2 y2 square plus lambda 3 y3 square. So lambda 1 you can take it as 0, lambda 2 3, lambda 3 15. So we'll have 0 into y1 square plus 3 into y2 square plus 15 into y3 square. So this becomes 0. So 3y2 square plus 15y3 square is the canonical form of the given quadratic form. We will write it in this way only, because that will finally help you to find out the rank, index and signature of the quadratic form. This is how we reduce the given quadratic form into canonical form.